Metallographic preparation of porous defects in metal 3D printing. 3D printed metal parts are one of the core application directions of industrial-grade 3D printing, forming by layer melting and solidifying metal powder with high-energy beams such as lasers, electron beams, etc. The control requirements for process parameters are strict. Different laser powers, scanning speeds, powder layer thicknesses, etc. will affect the density and mechanical properties of the parts. Today, we will perform metallographic preparation on the printed part, where these two different materials are combined. Observe how big the difference in porosity is between the two materials. First step, cutting and sampling. Use the TROJAN TableCut200 precision cutting machine with an A60 alumina grinding wheel, cutting disc for cutting. These are the cut horizontal and vertical samples, and a clear boundary line between the two materials can be seen with the naked eye. The second step, hot mounting. Place the samples neatly on the mounting sleeve platform. Use the MT1 hot pressing mounting machine with 2231 ordinary granular mounting material to produce samples with a diameter of 30 mm. The inlay is completed, and it can be seen that the sample is very tightly combined with the inlay material. The third step is grinding and polishing, using the 4-step metallographic sample preparation process. 1. First, use P400 silicon carbide sandpaper to grind the surface flat. The surface scratch status after grinding with P400 sandpaper. 2. Pause polishing disc plus 9 micrometers. Polycrystalline diamond polishing slurry for fine grinding for 5 minutes. Surface scratch status of PO's disc after grinding. 3 SC silk polishing cloth plus 3 micrometers polycrystalline diamond for rough polishing for 5 minutes. The scratch status of SC silk after polishing. 4. ET short fiber polishing cloth plus 50 nanometers silica polishing solution for fine polishing for 3 minutes. Surface condition after ET polishing. Clean the surface. Dry by blowing. Finally, place it under a microscope for observation. It can be clearly seen that the printed holes of the two materials are completely different. Pore defects in metal 3D printing additive manufacturing are one of its core challenges. They are essentially tiny voids formed by incomplete densification inside the material. These holes are unavoidable, and due to their tiny size and being hidden inside, they are difficult to detect, but it will significantly degrade the performance of the final part. It is a key obstacle affecting the application of this technology in higher liability fields such as aerospace and medical care.
Trojan. Discover the truth of material.